everyone. Let's go ahead and let's talk about the last thing in chapter 3 in our 3C assessment preparation. This is going to be how to deal with uncertainty. This is going to have to do with rounding techniques. So first one, let's round to the nearest whole number. That is going to be to this place value right here. So that 3 is going to cause us to round down. Remember, our rule says if the next place value over here is 5 or greater, we round up. If it's 4 or less, we round down. Round to the nearest tens place. That's going to be this place value. So that 2 is going to make us round down to the nearest whole number. It's going to be there. So that 8 is going to cause us to round up. The nearest 100, that's this place value. So that 7 is going to cause us to round up to the nearest tenth. Tenths, things with THs are to the right of the decimal place. So that 8 is going to cause us to round up again to the nearest tenth. So that 6 is going to cause us to round up. Nearest tenth. Again, so that 6 is going to cause us to round up. Nearest hundredth, we're here, so that 8 is going to cause us to round up. Nearest hundredth again, that 4 is going to cause us to round down. Nearest hundredth, so that 8 is going to cause us to round up. Nearest thousandth, tenth, hundredth, thousandth. So that 1 is going to cause us to round down. Nearest thousandth again. That 6 is going to cause us to round up. Thousandths place again. That 4 is going to cause us to round down. Thousandths place again, that 7 is going to cause us to round up. Now we're going to talk about significant digits. You might hear me actually say sig, figs, which stand for significant figures. That's usually what we call them in science class. So rules for significant figures are that 0 is that all non-zero digits are significant. Zeros that are between non-zero digits are significant. Zeros after the decimal point. At the end of the number. Like these, we don't have any of them, are significant. So, and then these always are. Always are. Always are. Rule number 4 says that the zeros before the first 0 number to the right of the decimal if the whole number is never significant. So for instance, these zeros right here are what I'm talking about. That those zeros leading up to that 4 are not going to be significant. And last is that sometimes zeros at the end of a number here, like this, call those trailing zeros. Are significant. It mostly has to do with this rule about zeros after the decimal point, and if there are zeros after the decimal point or not. So, all right, I'm going to erase all that so I can do some work here. Look those up in your textbook. There's a better chart there in section 3C. You'll see it, and it has like, I think it has 5 rules there, but it says them better than I could. So that's just what I remember off the top of my head. That's probably the hardest part of this section that I wanted to take a little bit to explain. And this mostly has to go to, if I write the answer in scientific notation, how many significant digits do I need to keep in my way that I write it in scientific notation, which we talked about scientific notation some last time. Okay, so this. That was a page number, that's why it doesn't erase. So that was my mark. Okay, all my blue is erased here. Go ahead. So forget this out here. So I'm not going to count those zeros at the end because I could. I'm going to start with this one. So there's 1, 2, 3, 4 because those zeros are between significant digits. So there are 4 sig figs, and it's implied that it's rounded to the nearest units or ones, whichever place value, however you learned that it was rounded to that place value right there. Right. This one is only going to have 2 sig figs. And it's implied, since that's my last unit that I think that I rounded to, that that is the 10 millions. My place value, the reason this one only has 2 sig figs is because I could write this as 5.1 times 10 to the 1, 2, 5, 8. And that would only have 2 significant figures in it. None of those zeros needed to be there to write the same thing in scientific notation. For kind of the same reason, this one is also only going to have 2 sig figs. And let's see, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions. Millions with a TH. For the same kind of reason, I could write this as 4.2 times 10 to the negative 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Looks like, and I'd only have 2 significant figures there. I'll zoom in a little bit here for you guys. All right. Now this one, these zeros are significant because they're between significant digits. So this is going to be 1, 2, 3, 4, 5, 6 sig figs. And that is tens, hundreds, thousands, 10 thousandths, 100 thousandths, 100 thousandths with a DTH. And this one, these zeros are significant because they've already written it in scientific notation. So they're telling us that every digit that they've written in scientific notation is significant. So there are 4 sig figs there. Tens, hundreds, thousands. And what they're showing us by writing those zeros there are that they have rounded to this particular place value. By showing us that, it shows us that it was probably a 1995 or 1996 or 1997, 1998 or 1999 or a 2000, 2001 or 2002 or 2003 or 2004. Could be any of those things that they've rounded to this particular place value here because those were their instructions, and that was significant to show us that rounding that they did. Okay, so this one here should again have 1, 2, 3, 4, 5 sig figs. Let's check my answer key so make sure that I'm right. Yep, 5 sig figs. And that one is rounded to the nearest 10th. Oh, I forgot to give you the correct answer. All right, so I need to take into account, back up here, I need to take into account this 10 to the 8th here. So this number here is really 2, 3. Keep in mind that that is where I rounded to, so I'm going to keep that underlined. 2, 3. 5, 6, 7, 8. So that is the 100 thousands. I needed to see where that place value was after I did the 10 to the 8th, and that's going to give me my 100 thousands place value. So this one is 5 significant figures rounded to the 10th spot. This is going to be 4 sig figs rounded to the nearest 10th spot. And then this one is going to be 1, 2, 3, 4, 5, 6, 7 sig figs rounded to the nearest thousandths with a DTH spot. Okay, easy enough. We just got a few more problems here at the end. We're going to do some math with our calculator, just and round it to the appropriate number of sig figs. So let me just show you that. If I put this on the right hand side over here, close this, pull up the calculator over here, all that. and show you 3602 times 50.41. And it tells me 2 sig figs, so that's going to be, these are the first 2 significant figures at 1 rounds down. So my answer here is going to be 1, 8, then 0, 0, 0, 0. Those are not going to be significant. I'm going to forget about the decimal part of that. Right of that. So this is going to be 180,000. Or I could write that as 1.8 times 10 to the 1, 2, 3, 4, 5. Okay. This is going to be 25.2 times 0.114. It says to write it with 3 sig figs. So that's going to be 2.87. There's no need to write that in scientific notation. That's going to be the same thing. 569 divided by 0.00244. And it says to do this with 3 significant figures. So that's again going to be that one. So it's going to be 2, 3, 3, 0, 0, 0. 233,000. Again, if I were to write this in scientific notation with 3 sig figs, that would be times 10 to the 5th. 946 divided by 0.0574. They only want 1 sig fig, so we're going to approximate that as 2, 0, 0, 0, 0, 20,000. And to write that as in scientific notation, it's going to be 2 times 10 to the 4th. Then for 27, we've got 5.8 times 10 to the 4th divided by 2.6 times 10 to the -9th. We want this with 2 significant digits, so that's going to be 2.2 times 10 to the 13th. If you wanted it the other way, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We're talking about this number. But I would give your answer in scientific notation. I'm going to box the way that I would give my answers. The other answer is not wrong. I'm going to box the way that I would give my answer for each problem, based off of the fact if it was given to me in scientific notation, I'd give scientific notation back. If it was not given to me in scientific notation, I'd probably not give scientific notation back unless I was asked to, or unless it was obvious it was a big exponent like this where the number was too big to write on the blank. So this is going to be -10 divided by 5.427 times 10 to the -5th. We want 3 significant digits. So that's going to be 4.05 times 10 to the -6th, like that. And if we wanted the long form of this, this would be 0.405. to go with this one for that answer because my answer was given to me in, or my question was given to me in scientific notation. So there's everything. That's the end of our stuff for chapter 3. See you guys in the next video where we start talking about chapter